Welcome back, ladies and gents, to Rock the JVM. I'm Daniel, and this is a gentle guide to options in Scala. Now, this video is aimed at Scala beginners, so I will assume nothing in this video, only your desire to learn the Scala language and the Scala standard features. So take your time and walk with me in this video. I will recommend that you code along with me, and whenever you need to refresh your memory about the concepts that I'm going to show you here, just refer back to this video or to the written form at the blog with the link in the description. The concepts that I'm going to talk about in this video are described and explained in detail and in depth in the Scala Essentials course with a link in the description below if you want to check it out. It has thousands of lines of Scala written from scratch and explains more than 100 examples and exercises if you want to check that out. Anyway, I'm going to go to my IntelliJ IDEA, and I've created a simple object called options with a main method in case we need to test some stuff. This will turn this object into a runnable application for those of you who are just getting started. And this video describes Scala options, and if you're learning Scala, I'm pretty sure you've accustomed yourself with the list type. So if I define a list as a list of int, you're probably familiar with generics as well. This, for instance, as a list 1, 2, 3, is a good example of a list of integers. And you can process these lists with map, flat map, filter, for comprehensions, and the regular Scala structures, which we also explain here on the Rock the JVM channel and on the blog, and of course in the Scala Essentials course if you know it already. So the list data type is the prototypical data structure which has all sorts of transformations. So for example, if we define a transformed list as a list.map and you pass a function from x to x plus 1, for instance, you'll get the list 2, 3, 4 in this case. You also have a function called flatmap. So let's say a transformed list, let's say version 2 as a list.flatmap, and the flatmap function takes a function argument from an element to a list. So I would say list with x and let's say x plus 1, and this will be the list 1, 2, 2, 3, and 3, 4, because for every element in this list 1, 2, 3, we obtain another mini list. So we have the list 1, 2 for element 1, the list 2, 3 for element 2, and the list 3, 4 for element 3, and all of these mini lists are concatenated together in one giant list. So we have map, flat map, and we have filter. So let's say a filtered list as a list.filter, and I would say x, let's say x mod 2 must be equal to 0, so we keep only those elements for which this predicate is true, and this will contain just the element 2 because the other elements do not satisfy this predicate. Because we have map, flat map, and filter, we have these sort of for comprehensions. So if we combine lists, let's say combined lists as a for comprehension, and I would say, let's say a number in a list with 1, 2, 3, and a character in list, let's say A and B, I would yield, let's consider an S-interpolated string with num dash character, of course with the $sign so that we can inject the values inside. So this will be the list 1A, so 1-A, 1-B, 2-A, 2-B, 3-A, and 3-B, because the for comprehension is expressed in terms of chains of map and flat map. So this will be identical to saying list 1, 2, 3 dot flat map, and considering a number inside, we would have the list with the characters, so A and B dot map, and for every character we obtain this little expression. So the for comprehension is equivalent to the flat map and map chains. This is rewritten by the compiler. I'm pretty sure you know all of these already because these are the fundamental building blocks of everything that we write in Scala. Now, why do I start with a list and I don't start talking about options? That is because options can be thought of as mini lists with at most one element. This is the beginning explanation for what options are and why we use them. So an option is a list in between quotes with at most one element. That is to say, an option either contains a single value or it contains no values. Now, you might be thinking at this point, why would we need a list with at most one element? Why can't we just use a regular list? An option has a philosophical reasoning to it, and before I start talking about why options are useful, let me discuss the main API of options so that we can build them, and then I'm going to describe why options are useful with some examples actually using options. So let me define an option as an option of type int. And much like we constructed a list with 1, 2, 3, here I'm going to construct an option with, let's say, an element 42. This will contain a single element whose value is 42, and the value for that is going to be a sum with 42. Sum is a simple class which contains a single value, which is a subtype of the main option type. We can also define an empty option which contains no value. Let's call this an empty option. Again, with an option int, and this will be option, let's say, empty. This will be a none, which is a singleton object, which denotes all empty options. So an option int, option string, option everything is a none. You can also define sum and none values explicitly. Let's call this an option version 2, which is again an option int. And by virtue of substitution, you can also say sum 42. This is the same. And similarly with none, we can build that explicitly. So I'm going to say empty option version 2, and instead of option empty, we will put the none here. But we prefer the option 42 and option empty because it makes more sense from the point of view of programming against an interface. So we consider option ints all of these values, option 42, sum 42, option empty, and none, but we treat them as options in abstract because of the reasoning that I'm going to show you in a few minutes. So this is the way that we can build an option either with a value or with no values. Now, let me describe the main APIs of options so that we can know how to transform them. So in the exact same case as we had for list, where map, flat map, and filter returned new lists, which were the transformations of the original list, the same can be said for options. So if we transform an option, let's say a transformed option, again, this is an option int, and I would say an option.map, and I'm going to say x arrow x times 10, for instance. This is again another option, so this will be a sum whose value is going to be 420. Similarly for flat map, so I'm going to say a transformed option version 2, which is again an option int, and I would say an option dot flat map, and much the same as we did for lists, we have a function that returns an option int instead of a regular int, as was the case for map. So I'm going to say x arrow, I'm going to say option with x times 10. And this is again sum with 420. Now, the mechanics of flat map for options is different than that of the lists because there's nothing to concatenate in a final list. We only unwrap the double options inside this function. If we had done a map, that would have been a sum of sum with 420, but because we use flat map, the nested structure of this option is removed, so we only return a single sum. So we have map and flat map, which are very similar with those of lists. We can also have a filtered option. Again, this is an option int, and this can be an option, let's say filter, and I want to say x arrow x bigger than 100. In this case, because the predicate does not pass for the value 42 contained inside, this option will turn into a none because the value will be filtered out of the option and we will leave an empty option. Cool. So we have map, flat map, and filter, and therefore we can also have for comprehensions. So you probably know already that for comprehensions are nothing special for lists. For comprehensions are available for all data structures which have map, flat map, and optionally filter. And these functions are available for options as well, and therefore we can run for comprehensions on options as well. So I can say, let's call this combined options as, again, an option of whatever. I'm going to simply run a for comprehension and let the compiler figure the type out for me. I'm going to have, let's say, a number in option 42 and a string in option Scala. I'm going to yield, let's say, a string injected here. String is the meaning of life, aka number. Something like that. So because we have map and flat map, we're going to obtain an option of, and the string here will be contained in that option, much the same as we had for lists. Okay, so we have map, flat map, filter, for comprehensions with options as we have for lists. So right now, you can think of options as lists with at most one element. Now, the difference between options and lists is that options have different APIs. For example, you can obtain an element out of the option, or you can test whether an option is empty. So I'm going to say, let's call this option API. I'm going to have check empty, and this is a Boolean. And you can test whether an option is empty or not. So I'm going to say an option, let's say, is empty. And this returns false if the option contains a value and true otherwise. You can also try to obtain an element out of the option. So I'm going to say inner value, which is an int. I'm going to say an option dot get or else, and I'm going to provide a default value, let's say 99, and the mechanics of get or else will be that the value will be returned from the option if it is there, and if it's not, this default value will be returned, and the end result will be an int. You can also chain options together, let's say a chained option, and I'm going to have, let's say, an empty option dot or else an option. And this will return another option int, whose value is going to be that of the first option if it is there. If it's not, then the value of the other option if it's there. Otherwise, if neither options will contain a value, then the resulting option will not contain a value either. So notice that the option API allows us to compose option values which basically denote the possible absence of a value. And I'm going to dive into the philosophical aspect of options, and I'm going to say that option will describe the possible absence of a value. Now, if you're just starting with Scala and you have experience in some other language, you probably know how we usually express the absence of value, and that is through the null reference. So let me go ahead and describe a small method. Let's call this unsafe method for reasons that will become apparent shortly. And I'm going to have an argument which is an int and returns a string. The argument type and the return type is not really that important, but the value may be null in some code flow. So for instance, if the argument is less than 0, then you'll return null. If some kind of code flow will not make sense to return a string, you'll return null. My problem with this method is that null does not really reflect the kind of value that this method is supposed to return. So you're saying you're returning a string, but you're returning null, which means that I, as the user of this method, will have to defend myself against the possibility of a null pointer exception. So this will have to lead to defensive code, which means that if I define a potential value, which is unsafe method with the argument, let's say 44, then because I know that this thing may return null, I have to defend myself against this possibility. Maybe I want to do an uppercase on the string and insert it into the database, for instance, to conform to some contract or some specification, but I have to defend myself against the null in some form. So if I have my real result in the following way, if potential value is equal to null, I'm going to return error or something like that. Otherwise, I'm going to return potential value, that to uppercase. Now this, in my opinion, is pretty terrible, because if all my method calls can return nulls, then I'm absolutely doomed, because I'm interested in writing some complex applications, and I have to combine values. So if I define, let's call this call to external service, for instance, which calls my unsafe method again, so unsafe method with, let's say, 55 or something like that, and I want to combine the two values, potential value and call to external service, by running some methods on them, I have to check against both nulls. So I'm going to have my combined result as the following. If potential value is equal to null, and if the call to external service is also null, then I'm going to return, let's call this error 1. Otherwise, I'm going to return error 2, because in this case, both of them are null. In this case, just one of them is null. Otherwise, I'm going to check again if call to external service is equal to null, then I'm going to return a different error, let's say error 3, and only then, in the final branch, I'm going to return a valid result, which is potential value dot to uppercase plus call to external service dot to uppercase, for instance. So notice how cumbersome the code becomes just to combine two values. Not to mention that in real-life code, we are processing large amounts of data and we're dealing with really, really complex logic, which means that our defensive approach to writing this sort of code becomes unsustainable, hard to read, hard to debug, and a headache for everyone that's going to read and use this code. Options to the rescue. So, in order to combine these two values together and call the unsafe method with options, we can do the following. I'm going to say, let's call this better combined result as a for comprehension, and I'm going to say the first value in an option which wraps the unsafe method, so unsafe method with 44, and if the result obtained from unsafe method 44 is null, the option with null will return that none thing, the none value that is the empty option. So this is pretty useful because regardless of whether unsafe method returns a valid string or null, option of that thing will return an option string regardless of whether it contains a value or not. And I'm going to continue that with a second value with option with unsafe method with 55. And now I have two potential values. And if there is a first value and if there is a second value, I'm going to yield, let's say, first value dot to uppercase plus second value dot to uppercase. So notice how compact our code becomes, and you can read this for comprehension a little bit differently for options instead of the list. And while you read the for comprehension for list saying for every number in list 1, 2, 3, for every character in list A, B, you will yield this expression. In the case for options, for comprehensions can be read a little bit differently because options mean a different thing. So you can read it for comprehension as considering the existence of a value inside this option, then let that be first value. Considering the value of option unsafe method 55, let's call that second value. If these two exist, then I'm going to return this expression combining both of them. And the result type is going to be an option string. If either of these options is empty, then the whole for comprehension is going to be empty because there's nothing to combine. And if eventually you want to surface an error out of this combination, if you see that either of these options is empty, you can say, let's call this final value as better combined result, and then you can say get or else. So if this combined result contains a value, that will be this expression. Otherwise, if either of these options is empty, then the whole option is going to be empty, and then you will return the value, let's say, error. All right. And in main, you want to print line, let's say, combined result, and then you will say print line for final value. And in this case, we'll have errors in both cases because our unsafe method returns null every time. So notice that we have errors in both cases. So notice that we can obtain the same result with code that's much, much more compact and more easily composable. So if we want to combine three options in this case, all we have to do is add another entry here in this for comprehension, whereas in the earlier result, our checks would have to double, because with 3 values, we would have to run 8 checks instead of 4, and so on and so forth. The checks blow exponentially. So this is the idiomatic way, the idiomatic Scala way of treating the possible absence of values using options and combinations such as map, flat map, filter, and these APIs such as isEmpty, getOrElse, or chaining via OrElse. So I would recommend that you use these when dealing with possible absence of values, and this will serve as a first best practice. If you ever deal with APIs that might return nulls, wrap them inside options. Or better yet, if you are the editor of these APIs, if you are the designer or programmer of these APIs, rather than returning nulls, make sure you return an option of the type that you want to return and force the users to safely deal with options in this way. So this is best practice number 1. I'm going to give you a bunch of other best practices as we go along. Cool, so I'm pretty sure that this makes sense at this point. Now, something that I see very often with beginning Scala programmers after dealing with options for the first time is a very interesting, almost organic itch to get the value inside the option so that you can do something with it. And I'm going to show you a best practice number 2, so best practice number 2, to resist the itch or the temptation to get the value inside an option, but rather use transformations such as map, flat map, filter, and for comprehensions. Let me show you what I mean by that. Let's say somebody gives you an option with unsafe method 44 and an option with unsafe method 55. So I'm going to say, let's call this first value as option with unsafe method with 44, and similarly I'm going to wrap this into 55, and I'm going to call this second value. And right now the for comprehensions and the transformations for options are not really second nature to you because you've just discovered options, and there is a very interesting itch to get the value 44 inside, or the value from the unsafe method 55 from the other option. So what you do is to say, let's call this combined result version 2, is to try to get the value. So I'm going to say if first option or first value dot is empty, then you're going to say if the second value dot is empty, then you're going to return error 1, else you're going to return error 2. Otherwise, you're going to check if the second value is empty, then you're going to return error 3, and only then you'll have both options having values. So you'll simply say first value dot get plus dot get dot to uppercase, because that's the transformation that we want to run, plus second value dot get dot to uppercase. That is if you're careful, because the get method is unsafe, and if the option that you're running get on is empty, then this get method will throw. But in this case, you've defended yourself against the possible throwing because you've checked whether both of these options are empty or non-empty so that you can run this expression. But notice that in this case, you've resorted to pretty much the same code as null checking in the first example. So instead of checking with nulls, you're now checking for is empty. The same kind of defensive code, the same kind of unreadability and hard to maintain debug and read and understand, and very easy for your teammates to hate you. So the itch to retrieve the value inside the option will get you back into the land of very defensive code. So this code is just as bad as dealing with nulls. The whole value of options is the ability to do these sort of transformations, such as for comprehensions, map, flat map, filter, OrElse, and all these sorts of things, and evaluate the option just once when you want to retrieve the final value at the end of all your computations at the end of the world. So I hope this makes sense, at least for now. And I'm going to give you a final best practice, and I'm actually going to call this best practice number 3, which is a warning, because I'm going to haunt you in your sleep if you ever do this. Never call sum with a null inside. this is why we try to avoid building some and none explicitly. We rather resort to the constructor option with a potential value which might be null, because if you by accident called sum with an expression that might return null, so let's say a bad option, as sum with unsafe method with 44, just because you think that this thing will not return null, you will kill us all, because through this guarantee, so I'm going to say an option string here, through the guarantee that you're building a sum, you already know that you have a valid value inside. It will never ever be null. So if you try to say a bad option dot get, this will not throw, because it will return a string per the contract of the option. But then if you call it to uppercase, then you will absolutely destroy us all. So if I try to printing this out, so print line this expression, you will get the same null pointer exception that you tried to avoid by using options in the first place. So notice the null pointer exception by the mistake of using sum explicitly on an expression that might return sum. So never call sum of null, and avoid using sum with some sort of expression explicitly. Alright folks, there you have it, a gentle introduction to Scala option, including the reasoning why we need options in the first place. I hope you liked this video and found it valuable. If you did, go ahead and click the like button for me and subscribe to the Rock the JVM channel for more videos like this. Check me out on Twitter and LinkedIn. I post fresh updates on the upcoming material. Check out the Scala Essentials course with a link in the description below. It contains detailed and in-depth explanations with dozens of examples and exercises about everything that we discuss about the Scala language. And finally, check out the Rock the JVM website and blog. I have hundreds of hours literally on everything in the Scala ecosystem, including libraries such as Cat's Effect, Akka, Apache Spark, and so much more. Until next time, I'm Daniel, signing off.